In a minute, we're going to go through and figure out how to turn a standard form parabola into a factored form parabola. But to start, I'm going to go the other way around. I'm going to start with a factored form, and I'm going to turn it into standard form. And the reason I'm going to do that is through this process, we'll be able to see steps of how to turn factored into standard. So if you did them in exactly the opposite order, you should be able to turn a standard back into a factored form. That's the idea. So if you can remember how to do this, that number in front always just sat around minding its own business. And then this multiplication says everything in this bracket has to multiply everything in that bracket. So x times an x, a -5 times an x, an x times a -7, and a -5 times a -7. So there you have that. Then I cleaned up everything, right? X times x was x squared. -5x minus 7x is -12x. -5 times -7 was plus 35. And then once that was all finished with the expansion, I could throw this number in front into the bracket. So 3 of these, 3 times -12 is -36. And 3 times 35 is 105. Okay, I'm just going to shorten this line up a little bit because it's taking up too much space. -5x minus 7x plus 35. There we go. Okay. So that's how you go from factored to standard. So I'm going to go through with this exact same question, and I'm going to try and do it in the other order. So what if I started with y equals 3x squared minus 36 plus 105? Well, the last thing I did in this process was to throw that 3 into the bracket. So here, I'm going to have to factor it out of the bracket. So the trick with factoring is you have to find a number that divides evenly into all of these things. And if you notice, looking at what's happening over here, do you notice that there is no number attached to this x squared, right? And the number we factored out happens to match the one that was on the x squared. That's always going to happen. You've got to peel this number here off. And by peeling it off the first term, you have to peel it off of all of them. So I'm going to see this as 3x squared. And I have to think about this. Oh, it should have an x on it. That's 3 times something. So take that, divide by 3, you get -3 times 12x. It's 3 times 12 is 36. And the same thing, this has to be something multiplied by 3. So you divide that by 3 and you get back to 35. So that's 3 times 35. And since I have 3 terms and every single one of them is being multiplied by 3, I can shortcut that by saying multiply all these things by 3. Right, that's what a number in front means. Instead of multiplying them all individually, just multiply them all once you get them combined. So we are successfully at this stage. To get to this stage here, I had to split the x squared into 2 x's, You left the 35 alone. Oh, actually, that was written as, I think I wanted it that way, as -5 times -7. You have to split this into two things multiplying each other, and you had to split this so that those two things would combine with adding or subtraction. Okay, this is sort of the place that requires some thought. X times X, that's easy. Now I need something with an X attached to it, something with an X attached to it, and then a number on its own, right? That's what I'm going for. Something with an X, something with an X, number on its own. Now, if you try and come up with all the things you can combine to get -12, this list actually never ends, right? It could be 1 minus 13, it could be 2 minus 14, it could be 3 minus 15, it could be 0 minus 12, right? This will go on forever that way and forever that way. So tactically, that's not the best way to hunt for these numbers. Because if you look at the back, the number 35, there are only so many numbers that multiply to 35. And if you keep in mind, this number, right, the thing with the axis attached, comes from that multiplied by that. So if I can find two numbers that multiply to 35, then I should be able to figure out how to split these middle ones. So if you can't remember and don't happen to have the example sitting beside you, just make yourself a list. 1 times 35, that would work. 2 times, doesn't work evenly. 3 times, doesn't work evenly. 4 times, doesn't work evenly. And you just keep trying this on your calculator, divide by 2, divide by 3, divide by 4. And unless it goes in evenly, don't write it down. And you've got 5 times 7, gives you 35. 6 times doesn't go in evenly. 7 times does go in evenly, but we've already accounted for that. So once you get something you've already accounted for, then you're done. That's the whole list. So this thing back here, 35, that has to be 5 times 7. That's where that had to come from. Okay. And 5, well, I actually maybe didn't know that yet. 5 times 7 would give me 35. I need to make sure that 5 and 7 give me 12. And they do. 5 plus 7 equals 12. I need it to be -12, so -5 subtract 7, which would make this one negative and that one negative there. If I've got this hot mess all up here, when you built this bracket here from these, you could see that I needed an X partnered with an X partnered with a -5, and a -7 partnered with an X, and a -7 times a -5 gave me that. And you're done. You've managed to take this factored form, standard form, and put it into factored form. So I'm just going to clear this off here, and we're going to try another example. So we've got an example here. Looks a lot like that one. Now I don't have the factor to standard to look at, but I do have this one. So if I look up here, the last thing you did going from factor to standard was to throw in this number. So the first thing we're going to do going the other way is to peel it back out again. So I look at that example up there, and I see a 2. I have to pull a 2 out of all 3 of those terms, the way I pulled a 3 out of all 3 of these terms. So y equals That'll be 2x squared. 8 I can split as 2 times 4 with an x attached. And 10 I can write as 2 times 5. So now that I've got all those things multiplying by 2 individually, right, just like this, I can shortcut it and say, don't multiply them all by 3 individually, just multiply the whole answer by 3. So out it comes, leaving an x squared, a negative 4x, and a negative 5. Okay, so I've done this part. Now I have to do this thing where I tease the whole problem apart. So this number here comes from the multiplication of these two numbers in that pod. So however I have to split this, I need two numbers that will multiply to negative 5. So what multiplies to negative 5? Well, negative 1 times 5, and 1 times negative 5, and that's it. Nothing else divides evenly into 5. So my two number combinations for these little pods here are going to be negative 1 and positive 5, or 1 and negative 5. So how do you choose which one it is? Well, these numbers, when you smash them together with addition, also have to give you this number in the center, right? Because the 5 times a 7 makes that, right? 5 times a 7 makes that, and a 5 plus a 7 gives you that in the center. So negative 1 and 5, if you added them instead of multiplying them, would give you 4, which is close, but it's the wrong sign. 1 and negative 5 would give you negative 4. That's the number you want and the sign you want, so that's the combination we're going to need. So I'm going to take this expression here, leave the 2 in front. X squared is an x and an x. I'm going to split this as negative 5x and plus 1x. And that there will be 1 times 5, right? Negative 1. I guess you said the negative was in here. And if I split that into these two brackets, I can see that I got this term from an x and an x. I got this term from an x and a negative 5. And I got this term from an x and a plus 1. And 1 times negative 5 gives me that. So there I go. I finished factoring this. So this is a factored form. I think my yellow is nearing the end of its life. Okay, so when you went from factored to vertex or to standard form, you had to spread these two brackets into each other and then distribute this number. So if you're going backwards, you have to peel that number out and then re-break this back into two pods. So here's an example of a standard form thing, and we're going to write this parabola in factored form. So should fix that for the last one. Doesn't matter. I have a number out here in front. Very first thing we've got to do in this process is to pull that number out. So I need to write all of these things, all of this number, and this number as half of something. So this will be half of x squared. 2x would be half of 4x. Let me just check that. Is half of 4 2? Yes, it is. So it's all good. This number back here has to be 1/2 of 16 would be half of 32. And it's negative, so there you go. Now that I've done that, instead of cutting all of them in half individually, I can just pull it in front and say do it all in one go. So y is 1/2 x squared plus 4x minus 32. Now I want to break this. I'm going to break it into 2 pods like that. That's what factored forms look like. I'm going to need 2 numbers here. And if you can remember from the other examples, those numbers, whatever this is and this is, they have to multiply to 32, and they have to combine with adding to make 4. So I'm going to make a list of things that multiply to 32. You have to multiply to negative 32. This might be a long list. It'd be 1 times negative 32. 2 times negative half of 32 is 16. 3 times does not go in evenly. 4 times negative 8 goes in evenly. 5 does not go in evenly. 6 does not go in evenly. 7 does not go in evenly. 8 goes in evenly, but we've already got an 8, so I know I've looped around the whole list. So these 2 numbers are either 1 and 32, 2 and 16, or 4 and 8. So those are the only sets of numbers that multiply to negative 32. From this list, I'm going to pick the combination that also gives me positive 4 if I add them instead of multiplying. So 1 and negative 32 would be negative 31. That's definitely not it. 2 and negative 16 would be negative 14. That's definitely not it. 4 and negative 8 is negative 4. Well, that's the right number, but it's not the right sign. So what if I switch these around? Negative 4 times 8 is still negative 32. Negative 4 plus 8 is positive 4. So that's the combination I want. So if I take that line, I'm going to write the one in between. And I think when you've done enough of these, you're going to skip this line. But for now, I'm putting it in so it's complete. I'm splitting x squared into x and x. I'm splitting my 4x into negative 4x and plus 8x. And negative 32 as negative 4 times 8. And I ran out of space. So when I go to split these brackets up, x times x comes from an x with an x. X and negative 4 comes from an x and a negative 4. 8x comes from an 8 and an x. And 8 times negative 4 goes there. So I have successfully factored this standard form parabola into a factored form parabola. Now you'll notice that it didn't matter if it had a number in front that was a whole number or if it had a fraction in front. The process was exactly the same. You just had to peel the thing out first and then do this split where you're hunting for 2 numbers that multiply to that and add to that. I'm going to do one more example with a negative and then it'll be good for the practice problems. All right, so another example. I see a number out front. It means I'm going to have to pull this out of every single term before I can split into my 2 brackets. So I need to write every single one of these things as negative 3 times something else. So negative 3 x squared, negative 3. So what would I have to multiply by 3 to get 15? Well, that's 5. Negative 3 times positive 5 would give me negative 15. So this is going to have to be negative 2. Negative 3 times negative 5 is positive 15. Swim back here. I think that's 24. 3 times 20 would be 60. 3 times 4 would be 12. 60 and 12 is 72. Negative 3 times 24 would give me negative 72. So I need this to be negative. Negative 3 times negative 24 is positive 72. Now that I have them all individually multiplied by negative 3, I can write it in front. So to just say, just multiply them all by negative 3. Then an x squared, and a negative 5x, and a negative 24. We need to find a list of numbers that multiply to negative 24. Oh, it's going to be long. Negative 1 times 24. 2 divides evenly by 24, 12 times. 3 goes in 8 times. 4 goes in 6 times. 5 does not divide evenly into 24. 6 does. We already have one of those though, so I know I've created the full list. So any of those number pairings could go here and here because they multiply to negative 24. I need the pairing that also adds to negative 5. So negative 1 and 24 would be 23. That's not it. Negative 2 and 12 would be 10. That's not it, because I'm not getting negative 5 here. Negative 3 and 8 is positive 5. Well, that's the right number, but it's not the right sign. Negative 4 and 6 would be 2. That's not the right number at all, so that one's off the list. It has to be this pair. The sign's wrong, so I'm just going to swap them like so. 3 times negative 8 is still negative 24, but now it adds to negative 5. So that is the pairing you want. So I am going to write that in between step. You don't have to if you can go straight from these numbers to this. Just so you can see it, there's this negative 3 here. X comes from an X and an X. Negative 5 is coming from a negative 8x plus a 3x. And negative 24 is coming from a 3 times a negative 8. So when I split up these things into these two brackets, x and x comes from x times x. X times negative 8 comes from x and a negative 8. 3x comes from a 3 and an x. And 3 times negative 8 goes there. So I have successfully factored that problem.